Let's talk next about backing up data in BigQuery. We've already talked about multi-region datasets in BigQuery, but it's worth mentioning them again in the context of backups, because when you choose a multi-region configuration for your datasets, the data is automatically replicated across multiple regions. For example, if you have a multi-region dataset in the United States, the data is distributed across several data centers in different states, and similarly, if it's configured in Europe, it could be spread across locations across Europe, like the UK, the Netherlands, Germany, Switzerland. So this feature ensures a higher availability than regional datasets, and it ensures more durability, meaning that if one location goes down or experiences an issue, your data remains accessible and safe in another location. It's important to note, though, that this kind of replication is primarily designed to protect against large-scale disasters or failures, such as a data center going offline. It's not designed to recover from user errors like accidentally deleting or modifying data. If you accidentally did that, then it would be deleted or modified across all the regions that it's replicated in. So while replication offers significant protection for data centers going offline for one reason or another, you'd still want to use other features to recover from mistakes on a user level, and we're about to cover those as well. On that topic, let's talk about the time travel feature in BigQuery, something that's really quite amazing and super convenient. On the screen, we have a timeline where the left is in the past and the rightmost part of the timeline is the present time. What time travel does in BigQuery is it keeps a version of your table going back 7 days. So each of these dots represents a day in the past, just to kind of mark the distance. And it's not storing a new version each day, though. It's storing new versions of your table constantly. So throughout this entire timeline, it's constantly creating new versions of your table. And what this allows is for you to add a snapshot decorator to your query, where you can specify the time in the last 7 days where you want to query the state of the table. So it effectively acts as if it is that time that you specify when you add this decorator to your query. So to summarize, BigQuery's time travel feature allows you to view and query the state of a table from any point within the last 7 days. This lets you essentially travel back in time and look at how your data appeared at any given moment during that period. You can do this by performing a point-in-time query, querying the table as if it was at a specific time. And to do that, you use this snapshot decorator that we mentioned earlier in this slide. And you'll see that in the query syntax as for system time as of, followed by your chosen timestamp. It's good for situations like fixing accidental changes, performing audits, debugging, recovering from app errors, or performing a comparative analysis or even trend analysis with past data. This capability provides the lowest recovery point objective out of all of the backup options in BigQuery, meaning that there's virtually no data loss, making it incredibly useful for ensuring data consistency and availability. That's why I said it's really quite amazing and useful. So of course, it does have a limitation in the sense that it only goes back 7 days, but in most cases that gives you enough time to do any amount of recovery that you need. And it's a pretty amazing feature overall that not all databases have. Okay, snapshots also are a standalone option for backups. Snapshots offer a manual, on-demand way to create backups of your data at a specific point in time. And unlike time travel, which only goes back 7 days, snapshots are especially useful for long-term archives, allowing you to keep records indefinitely. Snapshots are especially great for use cases like compliance, audits, maintaining historical records. It's important to think of them as a way to preserve data over time for very specific purposes where regulatory or auditing requirements may demand long-term storage. So they give you full control over when and how your backup gets made and gets stored. So then they are great for long-term data retention and archiving beyond the 7-day time travel functionality. So that's why I'm mentioning them after the time travel feature. Another way you can back up your BigQuery data is actually just to export it to cloud storage. You can export tables in formats like CSV, JSON, and Avro, depending on how you plan to use the data or restore the data later. One reason that you could want to do this over other options is that exporting to cloud storage is generally cheaper than keeping it in BigQuery, particularly if you are using more affordable storage classes like ColdLine or Archive, and you don't need to access the data frequently. Another strategy you can take to rectify errors is using time-partitioned backups. So with time-partitioned tables, your data is split into specific time frames, such as by day or by week. This helps you to manage data in smaller, more focused chunks. And so you can back up these individual time partitions to cloud storage. Then if an error occurs, you can restore or analyze only the affected partition, which saves you from dealing with the whole data set. This approach cuts out unnecessary work and makes it easier for you to target and resolve errors by focusing on specific time frames. It's a more efficient way to handle issues without having to kind of review everything. And this strategy of using time partitioned backups to rectify errors could be tested on the exam. That's what you need to know on backing up data in BigQuery.